If you are aiming for strong result in maths, this video is for you. Hi, I'm Terry. With over 25 years of experience, I've helped thousands of students achieve academic excellence in SPM and maths. Express Notes will help you to revise key concepts quickly and effectively. Today, we're covering chapter 8.2, addition and subtraction of vectors. Let's begin. Okay, so we know that when two vectors they are added, right? The addition is called resultant vector. The result of adding vector is called resultant vector. And if they are parallel, we can just add them like how we add algebra. For example, a plus 3a is 8a. Because when they're parallel, the first vector can be expressed in terms of second vector. But what if they're not parallel? If they're not parallel, right, algebraically, we cannot add like a plus b is how many a? No, it's just a plus b. You can't do anything. But diagram-wise, we can use what we call triangular law or triangle law. Yeah, you go a here, b here. The outcome or the resultant vector is a plus b. It looks like this. Now, we can do the same for parallelogram law, because parallelogram law is an extension of triangle law. It's just that, you see, this is your A, right? This is B, right? A parallelogram has two equal and parallel sides. So remember, when vectors are equal and parallel, they are actually the same vector. So this is B, so I copy and paste over. And then if this is A, right, this is also A. So if you add up, we know that A plus B is the same as B plus A. Okay. Now then we have polygon law. Polygon law works like this. This is vector A, B, C, D. The resultant, my arrow is backwards. The resultant should be this. Change the arrow. The resultant is going upwards. Yeah, A plus B plus C plus D. The resultant is measured from the starting to the final position. Just join together. Now for subtraction of vector, if you have two vectors, right, let's say vector A going here, vector B going here. Instead of A plus B will go like this, A followed by B. This is A plus B. But instead of going up, we go down. So your resultant will be this one. This going down is negative B. Yeah? Right? We just change the opposite direction. You have to do some drawing, but not a lot. Yeah. Normally in SPM, got a bit of drawing, but not a lot. Maybe a short question only. Okay, so a couple of things about all this addition and subtraction. One is a midpoint. So the midpoint, I have a formula here, but normally we don't use the formula in exam, use the long way. So for example, if I want to go from O to M, right, we can use O to A plus A to M. Look at my diagram, O to A to M. Yeah, and my AM is half of AB. We know AB, right? AB is minus A plus B. Minus A because it's going opposite direction. Or you can say OB minus O, yeah? So it's actually the same as A plus half minus A plus B. So when you expand the bracket, A minus half A, you get half A. Then you got a half B. If I factorize it, it's just half A plus B. So it's actually a short, shortcut. OA plus OB divide by 2. You see, if M is the midpoint of AB, then vector OM is just half of OA plus OB. Okay, another way of thinking is this, you can actually extend this, right? This is A, right? This is B, right? So the whole thing is A plus B, isn't it? The whole thing, let's say we call it D. The whole thing is A plus B. But since these two are equal length, these two must be equal length, right? This is a parallelogram. So OM is automatically half of OD. If my OD is A plus B, so just add together. Okay. Now, we also can use what we call a ratio, device of line segment like coordinate geometry. The mx1, mx2 over m plus n. We can use this, but let me show you the long way first. If I want to go from O to A to B, that gives us OP, right? So let me give you number like example. Let's say m is 2, n is 1. So OP is OA plus AP. AP will be what? Now, example, AP should be 2 over 3 of AB, right? 2 over 3, the whole thing is 3. Okay, and your OA is A. Your AB is negative A plus B. As you multiply inside, you should get 1 over 3A plus 2 over 3B. Yeah, you can use this shortcut. The shortcut formula looks like this, everyone. We go OP equals to 1 multiplied by OA plus 2 multiplied by OB divided by total ratio 3. So you notice the same, right? This is a lot faster, but usually in exam we use the long way, the standard way. But it's a good method, a good way to quickly check your answer. Okay, let me look at one example. Now this one has nothing to do with the one above. It's just drawing. We want to express OC in terms of A and B. So for me, I'll just draw like this. You can do A first, you can do B first, up to you. Maybe I do B first, B is easier. If I do 1B followed by A is going this way up. Will it ever reach point C? No. So I need to do one more B. This is how many B? 2B. This is 1A, 2A, 3A. Okay, so your outcome for part A, OC, it is 1B plus 3A. Now you can switch the position and say, can I do 3A plus B? Can. Yeah, 3A means I go 1 here, 2 here, 3 here. Sorry, I make a mistake. This is not 1B, this is 2B. 3A plus 2B. Yeah, this is 1B, 2B. So we can do it this way. Okay, next, on a given diagram, mark and label point D such that CD is B minus 4A. CD is B minus 4A. Okay, so how do you go from C to D? Okay, we know B is going this way up. So I'm going to draw B first, right? B is here. This is 1B. 1A is going up this way. Minus A is going down. Negative 1A, negative 2A, negative 3A, negative 4A. So this is negative 4A. So where's your D? Your D will be over here, this point. You're supposed to label, mark and label, right? There you go, put a dot, label it D here. That's your answer. In this diagram, P is the midpoint. So for me, I will label everything. Like OP is P, OQ is 2P because P is the midpoint. And then point S lies on QR such that the ratio is 3:1. Your vector OP is P, vector OR is R. So I'm supposed to find QR. QR is very simple. Look at the diagram. We go down, minus 2P plus 1R. Yeah, minus 2P plus 1R. Can I? Minus 2P plus 1R, or you can write R minus 2P. Okay, second one. If I want to go from P to S, right, I have to go P to Q, Q to S. Yeah, P to Q, Q to S. So PQ plus QS. PQ is just P, but QS will be 3/4. This part here is shorter, is 3. The whole thing is 4, so it's 3/4 of QR. We already know QR, so I'm going to sub inside. My QR is R minus 2P. Let us expand the bracket. 3/4R minus 3/2P. We can write R in front, P at the back. 3/4 minus 1/2. Yeah, 3/4R, 1/2P. Right, so this is another example that you all need to know. Sometimes they give in the form of parallelogram, sometimes they give form of rectangle, they can even give rhombus. The key is it must be quadrilateral, right? Or they may give you in the form of trapezium as well. So here we have rectangle ABCD, where AC is a straight line, AD is 15x. Yeah, AD is 15x. And this length from here to here is 15x. AB is 5y. Okay, BF equals to 2BF is FC. That means this is 1, this is 2. You can say FC is 2 times of BF, right? So first of all, before you go and calculate AE, right, can you tell me what is BF? Boyfriend. 1/3 of 15x. Answer is 5x, right? So if BF is 5x, right? If this is 5x, this should be 10x. All right, so if I want to go from A to E, let's find out your AC first, because they say AE. Okay, look at this one. Right? AE is 3/2. Okay, sorry. I shouldn't do this first. AEEC is 3/2. That means this is 3, this is 2. So your AE is 3/5 of AC. We need to find AC first. Okay, for AC, right, because this is a parallelogram, a rectangle, in a way it's a form of parallelogram, we can copy your 5y and paste it over here. So your AC will be 15x plus 5y. And when you times inside, cancel, this should be a 9x plus 3y. So I got my first part. The second part, EF means I can go E to C, C to F. You can do this way. Another way will be E to A, A to B, B to F. Now, I think although this is longer, this is easier. Why? Because we already calculated our AE. If you go direct, if you go this way can, but you have to recalculate your EC. Yeah, I don't want to recalculate my EC. I will know AE. So my EF, let me write this down. My EF will be E to A plus A to B plus B to F. EA is negative of AE. So I'll just add a negative in front. It's a negative of this. Then my AB is 5y. My BF is 5x. So let me write this as 2y minus 4x. Okay, guys, if you write minus 4x plus 2y, can or not? Can, yeah, it's okay one. We can just normally we put the negative at the back, positive in front, but if you don't arrange it, it's fine. Okay, so let's talk about this parallel lines. When two lines are parallel, the first vector is a multiple of second vector. Now, I just want to point out to you, because there are many ways to do it. There are actually two ways to do it. So, for example, let's say vector A. I don't want to rewrite this, so I will just explain and highlight from here. So, we have first vector AB, second vector CD. So, if AB and CD are parallel, yeah, if AB and CD are parallel, we say AB is a multiple of CD. So, we put a lambda there. Now, your AB, right, is 6A plus 9B. Your CD is 4A plus 6B. We can factorize 3. Notice I take out 3 here. This one, I can take out 2. Because these two are the same, right, we can actually cancel out. And from here, we say 2 lambda is 3, lambda is 3 over 2. Then we sub inside, we show that AB is a multiple CD, meaning they're parallel. There's another way. The second method is this. We say AB equals lambda CD, but we times inside, times the lambda inside. Then we compare the vector A with A here. Then we compare, we got compare vector A, we got your lambda is 3 over 2. Compare vector B and B, we got a lambda 3 over 2. So you can see that the values of lambda are the same. So therefore, your AB is lambda CD, then they are parallel as well. Now, why is it important that you know the second method? Because sometimes it is not parallel. But it's a bit rare. So far in SPM, rarely they test you that they are not parallel. But in the event that they're not parallel, we cannot use the first method because you cannot factorize them anymore. Just like this one. Look at the CEF. EF is given, right? Now, if I want to show that AB is not parallel to EF, so you notice I sub inside like just now, but this time I cannot factorize this because if you factorize that, guys, you take this one out, you take out 3, right? You're left with 2A plus, okay, maybe I write here, 3, 2A plus 3B. Then the second one, 9 and 12, you take out 3 with the lambda, you get 3A plus 4B. So you notice in this case, you cannot cancel this, no. Cannot cancel because they're different. So the way to explain or to show that they're not parallel is we write down, we expand the bracket, we compare our A, our first lambda is 2 over 3. Then you compare the vector B, our second lambda is 3 over 4. Then we say that different values of lambda, therefore they're not parallel. Yeah, understand the difference between how to prove they're parallel and not parallel? Because most of the time, they ask you to show that they're parallel, but yeah, there is a small chance they ask you not parallel, and this is how we do it. Okay. All right. Now let's look at example number 6 now. Okay. Example 6. Okay. We are supposed to find first part, vector OS. Okay. Now look at the diagram. This is a trapezium such that OP is parallel to QR and OP-QR, the ratio is 4:3. OP is 4P. QR will be 3P because 4:3, right? Then point S lies on OR such that OSSR is 1:3. You're supposed to find vector OS. Okay, so to go from O to S, very simple. To go from O to S, we can see from this diagram, the ratio is 1/4 OR. And your vector OQ, you know, right? What's your OQ? OQ is 2Q. So your vector OR is 2Q plus 3P. We can multiply inside. I write P in front, Q at the back, but you can choose to do the other way around. Doesn't matter. OS is 3/4P plus 1/2Q. How about vector PR? Okay, so for PR, I go one whole round. I go P to O, O to Q, Q to R. That's PR. Okay, so let us write PRS minus 4P. Minus 4P because it's going opposite direction. Plus 2Q plus 3P. You simplify 2Q minus P. That is vector PR. Okay, now next we need to show that SQ is parallel to PR. SQ is parallel to BR. Okay, I know SQ, we can go S to O, O to Q. We know OS already, right? SO is just negative of OS. Just put a negative in front. And OQ, we know is Q. Right? Let me highlight for you. S to O, O to Q this way. Now, let's simplify this. This will be 2 minus half is 3 over 2Q minus 3 over 4P. So I've got my SQ and I got my PR. I need to show that SQ is parallel to PR. So we start by writing SQ equals lambda PR. My SQ is 2Q minus P. Sorry, I think I wrote the wrong one. My SQ is 3 over 2Q minus 3 over 4P. My PR is 2Q minus P. So let's factorize this. Take out 3. Take out 2. Basically, I take out 3 over 2. This will be 2. Okay, sorry. I take out 3 over 4. If you cannot see, right? Okay, maybe I show you this way. I just multiply top and bottom by 2. So 6Q minus 3P over 4. This is lambda 2Q minus P. I'm doing very slowly here. Then you take out 3. You're left with 2Q minus P over 4. The over 4, I put it outside. With that, you can figure out what's the lambda, right? What's the lambda here? My lambda is 3 over 4. So meaning my SQ is 3 over 4 PR. If you can show that the first vector is a multiple of the second vector, meaning SQ must be parallel to PR. But the next, what we're going to do is we're going to find the ratio. The ratio of SQ PR. Right? We can take your PR and divide it here. I'm taking this PR over here, guys. I'm taking this PR here. I'm bringing it down. So your SQ PR is 3 over 4. SQ PR is 3:4. But for this question, it's actually finding P in terms of Q. So again, now we know if they're parallel, AB must be a multiple of CD. My AB is P minus 3x plus 10y. My CD will be half x minus qy. Let's multiply this inside. This should be half lambda x minus q lambda y. So, and again, we use the same method like just now. We compare the number in front, the coefficient of x. You should see the number in front of x is p minus 3, and the result is half lambda. First equation. The number in front of y is, let me use a different color, blue color, 10. 10 is negative qy. 10 equals to negative q lambda. Okay, so what we want to do is to find p in terms of q. That means we need to get rid of lambda. To do so, we can take equation 1, divide by equation 2. So p minus 3 divided by 10 is half lambda divide minus q lambda. We can cancel this two. Cancel lambda and lambda. P minus 3 equals to half divided by times 10 is 5. 5 over q. Because I'm finding p in terms of q, I bring the 3 over. P is 3 minus 5 over q. This is involving parallel, but they want us to first find BC and OE, and then find the value of unknown M, given that DA is parallel to BC. You can see DA is this line, BC is this line, given that they're parallel. Okay, so number one, we find out vector BC. Let me label your OA first. Your OA is A, and C is a midpoint. So automatically, this should be half A. This is also half A. OB is vector B, and we are finding vector BC. So to go from B to C, I go minus B plus half A. Minus B plus half A. So your BC, we can write as half A minus B. Now, like I said, if you don't arrange it, it's fine. I just thought it's better. We put a positive in front, negative the back. Now, next, how do you find OE? Okay, I want to go from O to E. And they say that BEEC is 3:2. So this ratio is 3. This is 2. So to go from O to E, there are two ways. Either you go B to O to B, B to E, this way down, right? Or O to C, C to E, also can, up to you. Okay, but for me, I like to use the result from part A. And part A, I know BC already, is going in the same direction. So we should use O to B plus B to E. O to B is B. B to E is 3/5 BC. Okay, 3/5 BC. Let us sub inside. This is B plus 3/5. BC is half A minus B. Let's expand this. My vector OE is therefore B plus 3/10A minus 3/5B. Now 1 minus 3/5 is going to give us 2/5. Okay, I got my vector OE already. Okay, so I got part A, I got part B. Next, point D lies on the extended line of OE, such that OD is m times of OE. OD is m times of OE. So OD is longer. OD is m times of OE. Do you know what's vector OE? Yes, I know. I can sub inside. OE is on top here. I sub in 3/10A plus 2/5B. Let us simplify this. 3/10MA plus 2/5MB. Now, we need to use this result because why? They say DA is parallel to BC. I already know BC. I just have to find DA, right? So up to you. You can do one shot. DA equals lambda BC. DA is D to O plus O to A. Your BC we know from the earlier part, half A minus B. Now my DO and OD, they're opposite. Everyone, this is my OD. I'm finding DO. So we just put a negative 3/10MA minus 2/5MB. You need to put a negative in front up because DO is negative of OD. And my OA, we know our OA is just A. Multiply this inside, half lambda A minus lambda B. Okay, let's put them together. This is involving A and A. Put them together. You should get 1 minus 3/10MA minus 2/5MB. The result is half lambda A lambda B. Okay, can we compare? 1 minus 3/10M is now half lambda. I'm comparing vector A. So, well, I can't do anything. I'll stop here. Let's compare vector B. The number in front of B is this. I compare with this. Then we can just drop the negative. 2/5M is just lambda. So let us sub equation 2 inside equation 1. 1 minus 3/10M equals half of lambda. Lambda is 2/5M. Yeah, so it's a bit long. We have to use the second equation here. Sub inside first equation so that we can give you a lambda and find M. So this one you can cancel. 1/5 M and 2 can cancel. I plus 3/10M. This is basically half M. You can't do mentally. Use a calculator. Half 1/5 plus 3/10. That will give us 1/2. My M is 2. Okay. So once you got M equals to 2, take this, sub inside equation 2 because you need to find your lambda. Your lambda is 2/5 times 2, which is 4/5. So DABC is actually your lambda. We know DA is now 4/5 BC. Drop the arrow, put DABC 4/5. Therefore, DABC is 4:5. DA is shorter. DA is shorter, BC is longer. The difference between collinear and parallel is that collinear you have what we call a common point. It's like if you have vector PQ here, and then you have vector SR. If I cut this line and I paste it over here, where your S and Q overlap, I just don't write S. So they are still parallel, right? Okay. So, but when in this case, there are a few ways you can write this out. We can say PQ equals to lambda PR, where P is your common point. QR equals lambda PQ, where Q is your common point, and QR equals lambda PR, where R is your common point. So in a way, you have more option. Yeah, you have more option. So now let's look at one example. Example number 9. Here, in this diagram, U and V, they are the midpoint of OX and UY. Okay. The ratio is YW is 1, WX is 2, OX is X, and U is a midpoint. So this should be a half X. This should be a half X. Okay. And this is your OY. Now, what we want to do is we want to express in terms of U, X and Y, vector for YU. So how do you go from Y to U? I think you can just use Y to, okay, let me write over here. This one maybe not enough space. Y to U is Y to O to U. Y to O is negative Y. O to U is half X. Guys, I'm going this way. Minus Y plus half X. Minus Y plus half X. When you simplify this, for me, I'll write half X in front, minus Y at the back. But like I say, if you don't do that, it's fine. Next, I want to find OW. Okay, so to go from O to W, I can go O to Y, Y to W. O to Y, let me write down, O to Y, Y to W. OY is just Y. YW is 1 over 3 of YX. Okay, 1 over 3 of YX. And what is your YX? Your YX is, you can use the diagram, minus Y plus X. Minus Y plus X. Okay, let me write down. Minus Y plus X. Let us expand the bracket. Guys, I cut short my working out. 1Y minus 1 3Y is 2 over 3Y plus 1 over 3X. Okay, I got my OW and YU. I want to show that OV and W are collinear. So OVW is this line. Okay, so when you're collinear, like I said, you got more option. We can use OV equals to, let me write here. You can write OV equals to lambda OW. We can say OV equals lambda VW, or OW equals to lambda VW. Up to you, whichever. For me, I look at what I'm given and what I'm finding. So I already have OW. So might as well use OW. Use this, right? I just have to either find OV or I find VW. So maybe I find OV lah. I think no need to crack your head, right? Just use the first one, the easiest, I would say. We first need to find what is OV. And to go from O to V, we can go O to Y, Y to V. It is already given V is a midpoint. These two are equal length, right? So we can say your OV is OY plus YV. OY is Y, YV is half of YU. So this is your Y. YU is minus Y plus half X. Actually, no need to write like this. It's already here. Yeah. YU, we already have it earlier, right? Half X minus Y. So let's multiply. This is half times half, 1 over 4 minus half Y. My OV is 1/4 X plus half Y. Okay, I got my OV already. Okay, next, we need to find lambda. We need to use OV equals lambda OW. My OV is 1/4 X plus half Y. My OW I got from the first part here. But for me, I just rearrange it. I put X in front, Y at the back. So it's 1 over 3X plus 2 over 3Y. Let us multiply inside 1 over 3 lambda X plus 2 over 3 lambda Y. Okay, let's compare. When you compare X and X, 1 over 3 lambda is 1 over 4. Lambda is 3 over 4. Okay, if you compare, or do you prefer to use factorization? I think I just use factorization. Sorry, I changed my mind because the previous method I used factorization, so I might as well stick to it. This one is x plus 2y over 4. This is, I take out lambda x plus 2y over 3. It's easier this way. We can just cancel these two and find out what's your lambda, right? Bring it up. Your lambda is 3 over 4. So if I can write OV equals 3 over 4 OW, we know that they're parallel, number one. But since O is a common point, remember, collinear, you must have a common point. If O is a common point, therefore O, V, W, they are collinear. Okay, one last thing. State the ratio OV-VW. Now, we know this OV-OW is 3:4, meaning this one is 3, the whole thing is 4. So what is this OV-OW? 3:4. So what is OV-VW? OV-VW will be 4 minus 3, you get 1, right? The ratio will be 3:1. So here, RS, vector RS is given. T lies on the extended line of RS. Okay, meaning this is R, this is S. T lies on the extended line. So meaning is collinear, right? So RST is given as 6P minus 9Q, where M is a positive constant. So find the value of M. Okay, so basically, we know RS should be lambda ST. Your RS is 3M minus 2B. Your ST is 6P minus 9Q. I think we can factorize your lambda here, right? 6P minus 9Q, we can take out 3, left with lambda, 2. Wait, sorry, we can't factorize, you have to expand 6 lambda B minus 9 lambda Q because you have a. Did I miss something? Oh, guys, I must be blind. Sorry, I didn't see this. There is another 1 minus 4MQ, sorry, equals to lambda. Your ST is 6P minus 9Q. Let us multiply inside 6 lambda P minus 9 lambda Q. When you compare the number in front, the coefficient of P, you should get 3M minus 2 equals to 6 lambda. I can't do anything because they're two unknown, can't solve it. Then let's compare the coefficient of Q, the blue one. We take 1 minus 4M equals negative 9 lambda. So let's take equation 1, divide by equation 2. So when you divide this, 6 divided by 9 is 2 over 3. The lambda will cancel each other out. So, but there's still a negative here. There's still a negative here. Lambda and lambda cancel out. Cross multiply 9M minus 6 is minus 2 plus 8M. Bring the 8 to the left. 9 minus 8 is 1. 6 minus 2M is 4. Then you take this, you sub inside any equation, we do equation 1. 3 times 4 minus 2 is 6 lambda. This is 12. 12 minus 2 is 10. My lambda is 10 over 6 or 5:3. And we're finding the ratio of RSST. So RS equals 5 over 3 ST. RSST will be 5 over 3. RSST, the ratio is 5:3. Here we have a trapezium where QR is parallel to PS. T is the midpoint. And QR PS is 2 to 3. This is 2. This is 3. Vector PS is 2A. Okay, that means what is PT? Let me work out this first. 2 over 5 of PS, right? PS is 2A. Answer is 4 over 5A. This PT is 4 over 5A. I work it out first. Okay, now vector PQ is B. And then QR PS is 2:3. That means QR is 2, PS is 3. Oh, we know PS, but we don't know QR. QR is T is a midpoint. Okay, sorry, I made a mistake. I look at the wrong ratio. Sorry. T is a midpoint. Sorry. So this is A and A. That's why it looks so weird, right? Doesn't look like 2 to 3. Okay, your QR is 2 over 3 of BS. BS is 2A. I used to look at the wrong one. This is 4 over 3A. So this one is 4 3A. Sorry. Okay. Now I want to find vector QS. To go from Q to S, we can go Q to P, P to S. That is minus B plus 2A. Answer 2A minus B. Roman 2. TR. How do you go from T to R? I can go T to P, P to Q, Q to R. TR. I will go this way. 1, 2, 3. Okay. So it works like this. Minus A plus B plus 4 over 3A. So your outcome is 1 over 3A plus B. I got my vector TR. Okay, part B. Given QU is KQS. Yeah, QU is KQS. To go from, I think we can sub inside first. QU, K times of QS. You know your QS, right? Okay, let me write down QS first. Let us substitute 2A minus B. This is 2KA minus KB. So we are supposed to find K, given that TUR are collinear. Okay, where's TUR? TUR is this. So we know TR already. We just have to find TU. And to find TU, right, just now I added this, right? Just go one round. TU is just T to P, P to Q, Q to U. Let me do this way. Let me write TU equals lambda TR. TU is minus A plus B plus QU. QU is 2KA minus KB. And your TR is 1 over 3A plus B. I sub in. Okay, take your A and A, put them together. Take your B and B, put them together. So for your A, right, I have T to Q minus, did I make a mistake? No, 2K minus 1, A, and then you have 1 minus K, B. This is lambda, you times inside, 103 A, 103 lambda A and lambda B. Okay, what we need to do is to compare. Compare A and A. The number in front is 2K minus 1. This is 1 over 3 lambda, first equation. Then you look at the number in front of B, is this. You get 1 minus K equals lambda, equation number 2. So let's sub equation 2 inside equation 1. Your 2K minus 1 is 1 over 3. Your lambda is 1 minus K. I will multiply over. 6K minus 3 is 1 minus K. 7K is 4. K is 4 over 7. When you're done, we are supposed to find the ratio TU UR as well. Okay, we know your TU is, we need to find a lambda first. We sub inside equation 2. Find your lambda. Your lambda is 1 minus 4 over 7, which is 3 over 7. So your TU is 3 over 7 DR. TU is 3, DR is 7, this is 4. That means TU, DR, 3 over 7, TU, DR, 3 is to 7. Sorry, very ugly. TU, DR, 3 to 7. Okay, let's move down a little bit. I just have to write TU, UR, 3 is to 4. Everybody, when you have two lines that intersect, they're actually collinear because you see, first I want to go from O to P. I can go O to A to B. So that means APC is collinear. So you put a symbol H here, right? You're supposed to find ratio for H. Then if I want to go from O to P using another way, I can go O to B, B to P, right? Now BPD is actually collinear. They're actually collinear. So I just want to find the ratio K. So most of the time what we need to do is we want to find two versions of OP. One is O to A to B, and we can sub in the H inside. Second version, O to B to P, we can sub inside the K, and we just compare the two versions of OP and solve them simultaneously. Yeah. So intersection, like I say, in a way, it is collinear as well. But just now, the previous question, right, collinear, right? You notice one is your lambda here. This is your lambda. Lambda is your first unknown. The second unknown is your m, right? So it's just, or your k, so it's just a different unknown. Instead of putting the ready-made unknown here, they didn't give you, you have to put the lambda here, right? Okay, so this one, the unknown is given, h and k. For your example 12, it is, what's the unknown here? H and k as well. Okay, so let me zoom out because I need more space. This question is a lot longer. Okay, example 12. Diagram shows quadrilateral OPRQ. Line PN and MQ, they intersect each other at point R. MN lies on OP and QR such that OM is 1, OP is 3. So this is 2. ON is 1, OQ is 4. So this is 3. Vector OP is B. So meaning this is 1 over 3B. This will be 2 over 3B because the whole thing is 1. Vector OQ is Q. So this is 1 over 4Q. This is 3 over 4Q. Okay, I want to find vector Pn. So for me to go from P to N, right? We go P to O, O to N. So this is minus P plus a quarter N. Minus P plus a quarter N. So we can write this as 1 quarter Q minus P. Okay, second one. How about MQ? MQ, we can go M to O, O to Q. M to O, O to Q. Let me write here. It is minus 1 over 3B plus Q. Yeah, M to O to Q. That's your MQ. I got my PN, I got my MQ. Next, part B. Okay, your given PR is H PN. PR is H times of PN. And MR is K times of MQ. Express OR in terms of HPQ. Okay, so your vector OR. So to go from O to R, I can go O to M, M to R. OR, O to M, M to R. O to M is a quarter P. M to R is K times of MQ. Just use the result. My MQ, you know, I know my MQ. My MQ is negative 1 over 3B plus Q. Let's expand the bracket. So my OR, I expand the bracket and I put my P together. So this is 1 over 3 minus 1 over 3 KB plus KQ. So I got, okay. Actually, I reversed my order, guys. I got Roman 2 first. It's okay. I got Roman 2 first. I'm sorry. I'm supposed to find Roman 1 first. Roman 1 is in terms of H. Roman 2 is in terms of K. When you go O to M, M to R, you're actually finding K first. If you want to find H, right? The OR in terms of H, I must go O to P, P to R. O to P is P, P to R is H, PN. This one, HPN. So we know PN, right? Everybody, I know Pn from the first part, which is 1 quarter Q minus P. Again, I factorize it out 1 minus H, P plus 1 quarter H Q. Okay, so notice what we have here is 2 versions of OR, 1 in terms of H, 1 in terms of K. We just have to compare them. Now for comparison, you can write the first one equals, let me write the whole thing here, equals the second one, and we compare this with this, the red with the red, green with the green. Okay, so for P, right, 1 minus H is 1 over 3 minus 1 over 3K. Can we multiply by 3? Make one of them as a subject, make K as a subject. K is 3H minus 2, equation 1. Can we compare our P? Okay, P, I do here. Our Q, 1 over 4H equals to K. Maybe we make H as a subject. H is 4K. So let us sub 1 in 2 or 2 in 1, doesn't matter. The moment you sub in, your H is now 4 of 3H minus 2. H is 12, H minus 8, 11, H is 8, H is 8 over 11. Wow, this is so long, right? I've got my H already. I sub inside equation number 1. I find my, I think equation 2, equation 1. H is 8 over 11 minus 2. This is 24 minus 22. 24, right? 24 minus 22, which is 2 over 11. So K is shorter. K is 2 over 11. H is 8 over 11. If this video helped you to understand addition mathematics better, give this video a like. And let me know in the comment which part of the topic that you find most challenging or which chapter you want me to cover next. If you want more practice, you can get my AdMaths book on Shopee or Lazada. Just search Teliti. For full step-by-step guidance, you can also check out my e-learning course or join my classes at Subtraction Teliti. And if you want to improve your AdMaths and score better in SPM, remember to subscribe to this channel. I'll see you in the next lesson.